Good morning, students. I am Dr. Ritika, the faculty of CSA department, as an associate professor in St. Andrews Institute of Technology and Management. Today, I am going to deliver the lecture on software engineering. Now, today we will cover the topic of requirement analysis and design. So, what is requirement analysis and design? Let's start our slides. What is requirement? A thing that is needed or wanted is requirement. A thing that is compulsory or necessary condition is known as requirement. Now shown in the figure, requirement is what, where, how, who, when and why. All are the questions related to the requirement of a software engineering. So now next slide is we will read about the type of requirements. Now requirements as shown in the figure, requirement is divided into two parts, functional requirement and non-functional requirement, where non-functional requirement is related with NFRs, that is the non-functional requirement, where non-functional requirement are qualities and constant, where constant related to business or technical and qualities related to traditional qualities and non-functional business requirements, where they are further classified into several parts like business agility, business audibility, business concept extensibility, and the traditional qualities are further divided into several requirements like availability, security, and performance or scalability. So, we can say the requirement consists of two types, that is functional requirement and non-functional requirement. The non-functional requirement based on the performance, security, logging and reliability. Now characteristics of good requirement. First, correct, it should be correct. Clear, it should be clear. Understandable, should be understandable. Ambiguous. Next, testability means verifiable, feasible, independent, atomic, necessary, implementation free, consistent, complete, non redundant. So, these all are the characteristics of a good requirement. Now, requirement engineering task. We will learn about some requirement engineering task. So, let us understand with this figure the problem with our requirement practices. With our requirement practices, what will be the problem rise? First, you can shown in the picture how the customer explained it, how project leader understand it, now how the engineer design it, how programmer wrote it, means coding program programming done by the software developers, how the sales executive describe it, and how project was documented. So next is what operation installed, how customer build, how to help desk support it, and what the customer really needs. The example says the problems with our requirement practices. So, firstly, we will read about we have trouble understanding the requirements that we do acquire from the customer. Second, we often record requirements in a disorganized manner. Third, we spend too little time verifying what we do record, and we allow change to control us rather than establishing mechanisms to control change. Now, most importantly is we fail to establish a solid foundations for the system or system that is that the user want to build. So these are the problem rise during the requirement practices. So, problem with our requirement practices are many software developers argues that first, building software is so compelling that we want to jump right it, means before having a clear understanding of what is needed. Second, things will become clear as we build the software. If our requirement is clear, if we understand what is needed, then we can clear the build of software. Project stakeholders will be able to better understand what they need only after examining early iterations of the software. Now, next is things are very clear rapidly if requirement engineer is a wastage of time. So, the bottom line is producing a working program and that all else is secondary. Now, next we can understand with an figure. First figure shows how I cannot start the project because the requirements are not clear. Now, second me you can understand start making something anyways, otherwise we will look unhelpful. If requirement we will not able to find the requirement, so we are not able to further move towards our project or software development. In the last, so our plan is to clearly hide our competence. So you think too much means in the third slide all requirement specifications are clear. Now we further move towards our project also. So, a solution requirement engineering begins the communication activities and continues into the modeling activity, builds a bridge from the software requirement into software design and constructions, allow the requirement engineer to examine the context of the software work to be performed, the specific needs that design and construction must address, the priorities that guide the order in which work is to be complete, the information, functions, and behaviors that will have a profound impact on the resultant designs. So these are the solution related to the requirement engineer. Now, requirement in engineering task, the seven distinct tasks are inceptions, initiation, elaboration, negotiations, specification, validation, and requirement management. So we will learn about all seven tasks related to the requirement and specification. So the some of the tasks may occur parallel and all are adequate the needs of the project. All strives to define what the customer wants. All serves to establish a solid foundation for the design and construction of the software. Now, these are the seven steps: inceptions, initiation, elaboration, negotiation, specification, validation, requirement management. Now, one by one, we will read about these seven steps. Now, first is the inception. Inception task, the requirement engineer asks a set of questions to establish what type of questions they will raise. First, a basic understanding of the problem, the people who wants a solution, the nature of the solution that is desired, the effectiveness of preliminary communications and collaboration between the customer and the developer. Now, second question which is in the mind during the inception task is these questions are the requirement engineer need to first identify the stakeholders, recognize multiple viewpoints, work towards collaboration, break the ice and initiate the communication. So these are the questions during the inception task in the requirement engineer needs, what requirement engineer needs and what requirement engineer asks. So first step of questions, next step of questions, and the final step of questions. These are the questions raised during the requirement analysis and specification in the inception task. First, these questions focus on the customer, other stakeholders, the overall goal, and the benefit. First is who is behind the request for the work, who will use the solution, what will be the economic benefit of a successful solution, is there another source of solution that you need. These are the first step of questions. Now next step, these question enables the requirement engineer to gain a better understanding of the problem and allow the customer to voice his or her perceptions about the solution. So first, how would you characterize good output that would be generated by a successful solution. So, what problem will this solution address? Can you show me the business environment in which the solution will be used? Will special performance issues or constraint affect the way the solution is approached? These are the second level questions. Now, final you can say set of questions are these questions focus on the effectiveness of the communication activity itself. First, the question which rise in the mind of customer or a developer, you can say, are you the right person to answer these questions? Are you answers officially? Are many questions relevant to the problem that you have? Am I asking too many questions? Can anyone else provide additional information? Should I be asking you anything else? So these are the questions which is rise in the first step, second step, or you can say next step and the final step. So next is the elicitation. Now what about the elicitation task? Elicitation task is difficult because problem of scope is identify the boundaries of the system or specifies too much technical details rather than overall system objective. And second is the problem of understanding what is wanted, what the problem domain is, and what the computing environment can handles. All are related to the information which is believed the obviously is open often. No problem of volatility because the requirement changed over time. So we can say the elicitation requirement is little bit difficult. Elicitation may accomplish through two activities: collaboration requirement gathering and quality function development. Next, elicitation work products. The work products will vary depending on the system but should include one or more of the following items: a statement of need and feasibility, a bounded statement of scope for the system or product, a list of customers, users, and other stakeholders who participate in requirement elicitation, a description of systems technical environment, a list of requirements, and the domain constraints that apply to each, a set of preliminary uses scenarios that provide insight into the use of the system or products under different operating conditions, and any prototype developer to better define the requirement. So these are the elicitation product works. Now next is the collaborative requirement gathering. Collaborating requirement gathering means meetings are conducting and attended by both software engineer, customers, and other interested stakeholders. Rules for preparation and participation are established. An agenda is suggested that is formal enough to cover all important points but informal enough to increase the free flow of ideas. A facilitator, that is customer, developer or outsider, controls the meeting. A definition mechanisms is used such as worksheets, flip charts, wall stickers, electronic bulletin boards, chat rooms are some other virtual forms of meeting. The goal is identify the problem, proposed element of the solution, negotiate different approaches, and specify a preliminary set of solution requirements. Now, quality function deployment. This is the technique that translates the needs of the customer into technical requirement for software. It emphasizes an understanding of what is valuable to the customer and then deploys these values throughout the engineering process through functions, information, and tasks. It also identifies three types of requirement. First is normal requirement. In normal requirements, the objective and goals stated for a product or system during meeting with the customer. Second, expected requirement. The requirement are implicit to the product or system where, where they contain fundamental that the customer do not explicitly state them. And third is the existing requirement, the requirement for further that go beyond the customer expectation, eh, and prove to be very satisfied when present. Now, third is the elaboration. Now, elaboration task is the software engineer takes the information obtained during inceptions and elucidation and begins to expand and refine it. So, it focuses on developing a refined technical model of software functions, features, and constraints. It can analyze modeling tasks like use case are developed, domain classes are identified along with their attributes and relationship. State machine diagrams are used to capture life on an objects. So at the end result, analysis model that defines the functional, informational and behavior constraint of the problem. Now developing use case we will cover, we have not, we will already done in the previous slides, but in next topic we will use all these use case in DFD, that is the data flow diagram. Now next is a negotiation. Now what is negotiation task? During negotiation, software engineer reconciles the conflicts between what the customer want and what can be achieved given limited business resources. Now requirements are ranked, it is prioritized by the customer, users and other stakeholders. Risk associated with each requirement and identified and analyzed. So, guess of development efforts are made and used to assess impact on each requirement to project cost and delivery time. Using an iterative approach, requirements are eliminated, combined, or modified so each part achieves some measures of the satisfaction. These in figure you can see the negotiation skills where other persons are related to there. What are the cultural sensitive, psychology analysis, languages, tactical versions, time, perspectives, all are related to the negotiation task. Now, next is the specification. What is specification task? Specification task is the final work product produced by the requirement engineer. So, it is normally in the form of software requirement specification. The SRS we will read more about SRS in our next lecture. So, it serves as the foundation of subsequent software engineer activities. It describes function and performance of a computer based system and the constraint that will govern its developments. It formalizes the informational, functional, and behavior requirements of the proposed software in both a graphical and textual format. Now, we will cover software requirement specification. We will more work on SRS in our next slide. So, next is the validation. It is the sixth stage of our requirement analysis and specification. Now, in validation tasks, the work produced as a result of requirement engineer are assessed for quality. The specification is examined to ensure that all software requirements have been stated unambiguously, inconsistencies, omissions, and errors have been detected and corrected. The work product conform to the standard established for the process, project, and the product. Now, informal review serves as the primary requirement validation mechanisms where the members include software engineers, customers, users, and other stakeholders. Now, next we will read about in validation task is do any requirement conflict with other requirements? Is each requirement achievable in the technical environment? that will house the system or the product. Is each requirement testable once we implement it? So these are the approaches related to the demonstrations, actual test, analysis and inceptions. So does the requirement model properly reflect the informations, functions and behavior of the system to be built? Has the requirement model been partitioned in a way that expose progressively more detailed information about the system? So these are the validation tasks. Now question which is asked when validation requirement is generated. First is each requirement consistent with the overall objectives for the system and product? Have all requirements been specified at the proper level of abstractions? So, do some requirement provides a level of technical details that is inappropriate at this stage? Is the requirement really necessary? Or we can say, does it represent and add on features that may not be essential to the objective of the system? Is each requirement bounded and unambiguous? Does each requirement has attribution? That is a source noted to each requirements. Now, last is the requirement management. Now, what is requirement management task? During the requirement management, the project team performance is a set of activities to identify, control, and track the requirements and change to the requirement at the time as the project proceeds. So each requirement is assigned a unique identifier. The requirements are then placed into one or more traceable tables. So the table may be stored in database related to their features, sources, subsystems, interfaces, dependencies. So all our traceable tables are placed at the end of the software requirement specification. Now, requirement analysis modeling. What are the analysis modeling? What are the goals of the analysis modeling? First technical representation means it provide first technical representation. It is easy to understand and maintain, deals with problem of size by partitioning, use graphics, differentiate between essential informations versus implementation informations, help in tracking and evaluation of interface, provide tools other than narratives text to describe software logics and policies. Now, what is a set of model? These are the flow orientation model which indicates how data objectives are transferred by a set of processing functions. Second, scenario based modeling represent the system from the user's point of view. Now next is the class based modeling defines objects, attributes and their relationships. Behavior modeling states of the classes and impact of events on these states. Now, what is requirement analysis? What will be the objectives? There are three primary objectives what the customer require: creation of a software design, and it can be validated once the software is built. So, all element analyze models are directly traceable to part of a design model and some part may be overlap. So, what is the purpose? It the main purpose is operational characteristics, indicates the software interfaces with other system, establish constraint that the system must meet, provide software designers with the representation of information, functions and behavior, provide the developers and customer with the mean to access quality once the software is built. So, what are the rules? Rules may show or may focus on requirement that is visible, oral understanding of software requirements, delay the constraints of infrastructures and other non-functional models, minimize the couplings, and provide values to stakeholders, and also kept as a simple as it can. So, domain analysis defines as the identification, analysis, specification of a common reusability capabilities within a specific application domain. So, what are the sources of domain knowledge? Are technical, literary, technical literature, existing applications, customers customer surveys and expert advice, current, future requirements. Other outcomes of domain analysis are class, reuse, functional behavior model, domain, languages. So, analysis modeling approaches show structure analysis and object oriented analysis. In structure analysis consists of data and processes that transforms the data as separate entities. Data is modeled in terms of any attributes and relationship. Also, process model to show input data, transformation that occur on the data, resulting output data. Now, in object oriented analysis, focus on classes and the manners in which they collaborate with one another to full customer requirement. These are the elements of analysis modeler. Scenario based elements, it consists flow orientation elements, behavior elements, and class based elements. These all are the analysis models. About all these we will read in detail, like data flow diagrams, state diagrams. We all are covered the topic in entity relationship diagram or in data flow diagrams. So flow orientation modeling we will cover in our next coming slides of DFD. Same as the scenario based modeling, that is the use case diagrams, we will both in this we will both use case and activity in DFT slides also. Class based modeling, same we will cover in DFT slides. Behavior modeling is same we will cover in DFT slide. So these are the summary related to analysis modeling, where object oriented analysis based on the scenario modeling, structure analysis, scenario modeling, class based modeling, and behavior modeling, and structure based analysis based on the flow orientation modeling. Now, what is design engineering? What is the purpose of design? Means customer requirement, business needs, and technical consideration all come together, and it provides details about software related to data structure, architecture, interfaces, and components. It can be accessed from quality, where it conduct the design, better design contain errors, omissions, inconsistent, and key design can be implemented. Now it must practice de, de-verifications and converges as designer selects from design component solutions, knowledge available through catalogs, textbooks, and experience. The designer also choose the collection that meets the requirement defined by the components we will choose. So, software design is an iterative process that will require the translate into blueprint for constructing the software. So, the design begins at a high level of abstraction that can be directly traced back to the data, functions, and behavior requirements. So, they may occur subsequent refinement leads to design representations as much lower level of the abstractions. So, from analysis modeling to design model consists of four. First, data or class design, which includes design of classes related to their data structure, architecture design, what will be the relationship between major structure elements and architecture style, design pattern, interface design, where software, the way of communication with system, and the component level design, where the elements of the software architecture into procedural descriptions of a software system. So In this diagram, you can see component level design where class based flow orientation behavior. Interface design means scenario based model, flow orientation model, architecture design, data class design, all are included in the analysis models to design models. What tasks set to the software design? Firstly, it will examine. Second, it will set an architecture style. Third, it will partitions the analysis modeler, which is allocated by the subsystems within the architecture. Create a set of design of classes or component. Design any interface required with external system. Design the user interface. Conduct component level design and develop a development model. These are the tasks set by the software design. Now, what is design quality? Why we need of quality? What is the role of quality? Means what is the importance of designing its quality? Means provide representation of software, accurate translation, serve the foundations. Without design, we risk building our unstable systems. So, the quality of design is assessed through a series of formal technical reviews or design walkthroughs. What are the goal of a good design? It must be implemented to all requirement. It must be accommodated to the implicit requirement desired by the customer. It must be readable and understandable. It should be provide a complete picture to the software. So, writing a clever piece of a code that work in one thing, design something that can support a long lasting business is quite another. The design quality guidelines. What will be the guidelines for designing? Means what will be the steps we will follow for designing the quality. Means first is architecture. Which type of architecture we will recognize to create a architecture styles or patterns. Now, what should be the modular? Means logical partitioning of the elements or subsystems. Next, contain distinct representations. Means representation of data, architecture and components. Design leads to data structures that are appropriate to classes. Design leads to components that exit ex, that exhibit independent functions characteristics. It should lead to interface that reduce the complexity connections. Also used to representable methods driven by the information of a software requirement analysis and several other notations. So designing concept we will soon cover in our next PPT. Now designing model are the various four types: component level design, interface design, architecture design and data class design. So these are the dimensions of the designing models as we have shown in the picture: analysis model and design model. Design model are further classified into various elements. So let's introduce our design model. Design model are of further two type: horizontal and vertical. Or in horizontal it indicates the various parts of designing model, and in vertical it indicates the representation of levels of details. So it use many of the same like UML diagram, that is unified modeling language, during the designing of the model. So it may be refined or elaborate, or it may be implemented specific details. So introduction is continued with the design model, which are not always developed in a sequential fashion. Maybe depends upon the requirement, or feel free we can design with the help of UMLs. Maybe data or class design, architecture design. So depends upon the requirement, depends upon the uses of the software we will use during the designing part. So in this we will follow all other development level designs also. Designing elements may be class or data design, architecture design, interface design, component level design. These all are the parts of UML which is not in our syllabus, but in our previous slides we will design, or I will try to design, or I will try to cover the topic of UML, that is Unified Modeling Language. In UML we will all discuss about data class design, architecture, interface, component level. We all design in this slide. So what are the important questions? What are the steps for requirement analysis and design? What is the purpose of designing? What is the niche of requirement analysis? What are the characteristics of a good requirement? So these are the questions based on the above slides which I have given on the topic of requirement analysis and specification. So thank you so much students. Now in our next slide we will cover whether we will try to cover our DFD ER diagram, try to cover both topics as the topics are very vast. Otherwise we will try to cover some SRS requirements. So thank you so much students. Thank you.